Right, good afternoon everyone. So the context of today's agenda will go as follows. There's an intro, there's a bit where I explain, there's a bit where I model, there's a bit where I visualize, and there's a bit where I productionize. So to kick things off, what is Metal? So that's the company I work for. Well, we are a free digital business account for UK self-employed people. And our purpose is to give people the financial confidence to turn their passion into opportunity. We're like Monzo, but for business banking essentially. Who am I? Well, I work at Metal. I'm a data scientist there. I work closely with our growth and marketing teams, and I've previously given talks, as you've seen there. So I'll go to the bit where I start explaining what this presentation is about. So to begin with, what is attribution? In this case, it's essentially knowing that our customer X comes from channel Y, where a customer refers to someone who is a customer of Metal, someone who downloads that app and uses it. And channel refers to the place where they came from. So did they download our app because they saw an advert on Google, Facebook, Money Supermarket, etc. So why do we care about attribution? Well, we pay to advertise on channels like Google, Facebook, and so on, so that we can acquire customers from them. And knowing how many customers you acquire from each of their channels allows us to minimize the costs to maximize the number of customers we get. But attribution is misleading. So to give you a context, our data says that over 50% of our customers come from organic. Organic means word of mouth. So your friend Bob or your friend Haiti told you about Metal. But that 50% is exaggerated because not many people know about Metal. We don't have very big brand awareness. People who see our ads don't necessarily click on the ad to download the app. Behavior tends to be that you see an advert. Let's say you see an advert for milk, and you don't click on the advert. Instead, you open up Google, you search for that milk, and then you click on the search result. The way that technology works is that because you do not click on the ad, the data does not show that you come from, let's say, that Facebook ad. Instead, it shows you came through word of mouth, and that's also a key reason. And also, Apple IDFAs like Google Flock, that's where the industry is becoming more privacy-centric, and it's hard to identify individual people in your data. So those are the three reasons why we believe that 50% is a gross exaggeration of how many people are actually coming from our organic channel. So it's problematic. That 50% should some of that should be coming from Facebook, Google, Money Supermarket, and because they're not being attributed correctly, that means in our data and in our analysis, we are not treating the channels as they should be. It might be the case that Facebook, in our data, it says that 50 people come from Facebook, but in reality, because of the attribution issues, 70 people should be coming from Facebook. So how do we bring that extra 20 people from Facebook into our data? Well, we model it. What do? Well, we reframe the problem to think about how much organic traffic can you explain by the number of clicks you have on each channel. The key word here is explain. We're not trying to predict, we're trying to explain. So this is where we start using some econometric methods. So we start off with a very basic time series linear regression model, where our inputs are Facebook, Google, and Money Supermarket clicks. And what we're trying to explain, what our output is the organic customers. And then how do we test it? We look at the associated F-score, t-test, and adjusted R-square. We build that model, we test it, and then we iterate and improve based on what we see and what we understand when we talk to other people in the company, our marketing team. So we then move on to use a ridge regression, we start talking about sliding windows, and then we then move it towards a weighted least squares regression. Now, within this model, because our focus is on explainability rather than prediction, that means we don't use scikit-learn. What we use instead is stats model, and the reason why I use stats model is because it has much more better inferential capabilities. So it tells us how much do the inputs contribute to our outputs. How well does Facebook explain organic customers? And then when we talk about ridge regression, part of that is because in a regression, you typically remove variables that aren't influential in explaining, but because you want to understand the role each channel plays in explaining organic customers, we apply a ridge regression like that. We use a sliding window so we can say, do you want to focus 50 days back, 60 days back, 200 days back when I'm building a model? And then we use weighted least squares because we want to place more emphasis on recent data relative to older data, especially in the context where you have upcoming brand campaigns. So that's why we iterate and improve. So we talked about F-scores, t-tests, and adjusted R-squares. What do they mean? Well, to benchmark a model, we take the F statistics, especially the p-value associated with it, and that allows us to say, that tells us if the model itself, i.e. whether channel clicks, can explain our organic customers. So as you can see from here, the value is less than 0.05, so it's significant. What we can say is our model is significant in explaining organic customers. Then we take that adjusted R-square, which tells us how much the channel clicks explains our organic customers. So you can see it's about 68%. So that means 68.6% of our organic customers should actually be attributed to marketing channels like Facebook, Google. And then we move on to interpreting it. So what we just saw is our model is valid, and our model explains about 69% of organic. So Facebook, Google, MySQL explains 69%. But how much does Facebook contribute that 69%, and so on and so forth? Well, the p-value for the t, that tells us if the channel the individual channel itself, not the model, the channel itself explains organic customers. So here I'm highlighting Google, and you can see that the p-value for Google is less than 0.05. So that means Google is driving something like 69%. Whereas if you look at Facebook, because that value is 5.86, it's larger than 0.05, that means Facebook itself is not driving any of that 69%. That tells us Google is driving it, Facebook's not. The next question is, how much of that 69% is Google driving? Well, that's where the coefficient comes in. So the coefficient tells us how much the channel explains organic customers. So in this case, you can see that Google is 13 and MoneySuper is 7. So that means Google is driving more of that 69% than MoneySupermarket. Bringing that all together, let's take a specific example. So say we have 100 organic customers for this week. From our adjusted R-square, that means 69 of that 100 organic customers should be attributed to Google, Facebook, or MoneySupermarket. Now, the channels that are making up that 69% are Google and MoneySupermarket because of those p-values we saw before. How much? Well, 44 of that organic should be going towards Google, and 25 should be going towards MoneySupermarket. And this is what we do to calculate that. By the way, this data is fake, so take it with a pinch of salt, but this is the general theory. But, we have a model. Models are models. They're not useful unless you actually put them to good use. So, yes, I've been able to quantify how much of that 69 organic customers should be going to Facebook and MoneySupermarket. But seldom I'm not making the decisions. It's the marketing team making the decisions on how much they spend on Facebook, Google, and MoneySupermarket. So how can they use this information to influence their decisions, especially on a regular basis? Well, you make this information, you make the output of the model available in a dashboard. So what we do here is you put that output of the model, put it to a dashboard that our marketing team uses, and they monitor this dashboard to understand how Facebook, Google, MoneySupermarket, how that evolves over time. So they see that Google's has the lowest cost per acquisition, i.e. to get the most number of people, they pay the least amount on Facebook. So they see that that's generally, across the time, that's generally quite low. So take a long-term decision to choose to invest most in Facebook, because that gives them the most bang for their buck. Okay, so the model was used and it was proven valuable. That's fantastic. But, you got to talk about productionize it, because everything's been experimental. We modeled it, we put it into the dashboard, but you got to maintain it as well. So, maintaining it is the hardest part, really. It's great to be able to service it to your customers and stuff, but to be able to maintain it, well productionize it, it's quite manual to maintain it. You have to run the model, get the data. What you want to do is productionize it, because that way you can save time. And you can save time to focus on more important stuff. So what do we do to productionize it? Well, we use an Airflow DAG. And to use an Airflow DAG, we split our code base up into operators. So we split it up into 5 operators. The first operator is a data ingester. So that's an operator that takes the data that we need on clicks and organic customers, takes it from a database, and puts it to a CSV file. We then have a feature generator operator, which then takes that CSV file, reshapes that data, and standardizes the data, so we can then model on it. Then we use a model inference operator to then apply the model onto that data, and then to create Pycon and CSV files off of that. And then we then have an acceptance test operator to check our outputs make sense and that they tie with business knowledge. It's our way of saying this model is correct. And then once it passes those acceptance tests, we have an output uploader operator, which then takes the model outputs and puts it back in our database, which can then link up to a dashboard so that every week the model runs, and then as the DAG runs every week, it updates the dashboard automatically. No need for myself to touch it so much. Why do we generate files at the end of this in each of those steps? Well, that's just to ensure that we have good traceability of if a problem does occur, like if the model does break down, we know which step 1, 2, 3, 4, 5, where that breaks down. So that's why we take steps along the way. So we have a well-used and productionized model now, which is used in the business, which is great. And also, we gave the model a name. Can you guess it? We called it a scam, which means this called channel attribution model. There we go. That's the end of my talk. Any questions?
You mentioned that you take data from the query, but where you get data first, before the query, what kind of data are you using?
Yeah, good question. So we take our data from various ad platforms. So we use Facebook, Google, Twitter, Money Supermarket, all sorts of these different platforms. And what we do is we use an ad platform called AppSumo and Branch. These sort of platforms take those data from each of those platforms, brings it all together, and then we load that into our BigQuery database. And by using those ad platforms, we can interface with each of these different areas.
But still, based on what data you're figuring out if it's Facebook or Google or whatever?
Yeah, so that's click data.
Based on what features?
Yeah, so it's click data. So when someone clicks on the ad, or when someone goes onto the website on Facebook or so on and so forth, that's related to Metal, the platforms capture that and they bring that information to us. And then we use that click data on each of those channels and say that's our input, and output is the number of customers that we know we have coming through as organic. So whenever we get a customer, someone who downloads the app and then gets an account with us, we capture information of where they came from through these ad platforms. So we have information that this person came from Facebook, we have information that that person came from Google. So we take those 2 bits of information from these ad platforms and then model that.
But IDFA is only available for the users who opted in, like the notification. So
Yes.
you're building only, building the model only for those users who opted in, and you can have some user level information stuff.
Yeah, so there's 2 types of information we're talking about here. There's the click information and there's also the acquired information. So the click information, we have better coverage on that than we do on the acquisitions information. So our visibility of where people come from to download the app is relatively worse than our visibility of when people click on something related to Metal. Because our click data tends to be has better coverage than our customer data, then we use the click data to infer on the customer data.
of times the ad has been shown, except instead of using the clicks? Because I guess the number you want to explain, so these, let's say 50% of organic customers, they are those normally who didn't click on the ad, right?
Some of them are people who might,
Okay.
who don't click on it.
Okay, but so some of them have clicked on the ad and some not. But would it work also just to count the number of times the ad has been shown to people?
Yeah, that's a good question actually. So that's what I think that's what we call impressions in the data. So how many times is an impression made on someone? That's actually a good point. I actually did look into that. So the number of times the advert is shown to someone depends on the platform. So the number of times an advert is shown to someone on Facebook might be more important in making them a customer than, let's say, Twitter. And I think I did look into that actually. And for some channels it didn't work, but for other channels it did. So I think Facebook impressions worked rather than click data, whereas TikTok, in TikTok it works better because of the way people use TikTok and stuff like that. So I was looking into the XI correlation there, and it did show that impressions was a much more stronger indicator of becoming a customer than click. It's not the same for all channels, but it is for some channels, and that's something that I've researched, that I've analysed. I haven't put it into the model yet, but that is something that's on the to-do list, on the backlog. Yeah. Good question. Yeah.
So two points. First, there are sort of two different modes of advertising going on. There's a cumulative. I've seen this company pop up on adverts several times, and therefore I think when I need to go and find something that does this particular thing, that company is in mind, and then I go and find it independently. And then I'm looking for something, and I search for it, and this one is sponsored link recommended. So, for example, the Google hits might be more representative of the latter, because you Google something and then you click on the link to go to get the thing. Whereas Facebook ads and things are kind of seen in the periphery, and therefore the mechanism is different.
Yeah.
So that's the first point. Second point, when you're analysing conversion rate data, Bayesian methods tend to be the thing that you reach for. Did you look at any of those? Did you use a MCMC sampling algorithm or something to refine your regression models or anything like that?
Yeah, okay, good question. So the first one actually touches upon the previous question about impressions. The more times you see an advert, the more it becomes ingrained in your mind, so you have a greater awareness, brand awareness of that company. So that's a different part of the marketing funnel. The focus that this model is on what you said, the conversions, but brand awareness does play a role into it. It's hard to quantify, but I have talked about how we can look at impressions and how impressions works better on TikTok. So that's on the backlog on ways I can improve the model itself. On the second question about Bayesian methods, I haven't looked into Bayesian methods. It's a good point. It's something that I would like to explore as a next step for the model itself. Yes?
Could you tell about context windows and how many data, like previous 2 weeks or one old data do you use for training data, and when the data becomes irrelevant?
Yeah, good question. So the training windows. So at a high level, reason why we iterated to use rated least squares is because we want to make the data more sensitive where we have an upcoming brand campaign. So if we're going to have a brand campaign on Facebook coming up, we want the model to rate more recent data more sensitively so we can see the impact that campaign has. But when we don't have one, we want to look over a greater time period because we want to consider much information in the model itself. Regarding how many days we look back and what gives us the most effective results, it tends to be about a year to about less than a year, so maybe 6 months to a year. That's where we have enough information, whilst at the same time not making it too that's when we have enough information to be able to get valid model from the F-score, but at the same time, not having it at too short a time period that is useless. Any further questions? Yep.
You continuously adjust the spending in marketing depending on that month, in an automated way, or is it?
Yeah, so is it automated? It's automated insofar as the marketing team have regular weekly meetings where they review how the recent campaigns went, how the recent spending was, and activity, and they make judgments based on this information plus other contextual information, and they make decisions on a weekly basis on then how much you spend on this campaign or that campaign. Thank you. Yes?
Well, basically there are several similar models on the market. For instance, Meta has Project Robin, and Google has launched Pycon mixed model. Which one does the same thing? Have you tried to compare the results of your model to those of alternatives?
So I didn't actually know that Google or Facebook had their own models. But the reason why we did our own model is because like Facebook models mainly for Facebook data, and we're using multiple channels. We're not just using Facebook, we're using TikTok, we're using Twitter, we're using Money Supermarket, we use a whole load of other websites, and they're the platforms that we get the data from is different to Facebook. So us trying to build our own model is a way for us to get consistency across each of our platforms to treat them fairly. In terms of how our model compares against those ones, I haven't looked into though.